Welcome back to the deep dive. Today,
Okay.
we're going to be cracking the code on one of JavaScript's most
Mm-hmm.
misunderstood concepts,
Right.
prototypes.
Yeah.
Get ready to unravel the secrets of this powerful system
Yeah.
and finally understand why it's the backbone of object-oriented JavaScript.
You know, prototypes are often explained in a way that makes them feel very abstract, but really,
Yeah.
once you get them, it's like a light bulb goes on.
For sure. And I think a lot of people get hung up on the terminology, but it's really not as complicated as it sounds. You don't need a computer science degree to wrap your head around this.
Exactly. In fact, a good way to think about prototypes is to think of baking. Let's say you have a recipe for a really great cake. That recipe is like a prototype in JavaScript. It's a blueprint that other cakes can inherit from.
Okay, I'm following you. So instead of starting from scratch every time you want to make a new cake,
Right.
you have this base recipe, this prototype that you can build upon.
Precisely. And just like you can add chocolate chips or change the frosting to create variations on your base cake. In JavaScript, you can add properties and methods to create objects that are customized versions of your prototype.
That makes a lot of sense. But how does that actually work in JavaScript? I mean,
Yeah.
we don't have literal cake recipes in our code, right?
Right, of course, but the concept is similar. Let's look at a simple code example. We've got a snippet here.
Okay,
Const car, wheels, 4,
okay.
const my car, object.create car, console.log mycar.wheels.
All right, let's unpack that. We've got this car object, and it seems like that's our prototype. But then there's this object.create thing. What's going on there?
That's where the magic happens when we use object.create car to create my car. We're essentially telling JavaScript,
Okay,
hey, make my car inherit properties from car.
gotcha.
It's like saying, make my car a specific type of car
Right.
based on our car prototype.
So it's kind of like my car is a child of car, and it's inheriting all of the parent's characteristics.
Yeah. Yes, exactly. Think of it like a family tree. Every JavaScript object has a parent, a grandparent, and so on, all the way back to the very first object, and they all inherit traits from their ancestors.
That makes sense. So when the code tries to find the value for mycar.wheels, it checks my car first. But since my car doesn't have a wheels property directly defined, it goes up. The family tree checks its parent car and finds the value there.
Spot on. That's what we call the prototype chain.
Okay.
JavaScript climbs up this chain of ancestors, checking each prototype in the line until it finds what it's looking for.
Right.
It's like asking your parents for something. If they don't have it, they might ask their parents, and so on, until you find what you need.
I'm starting to see how this whole prototype thing is pretty powerful.
Yeah.
Like a system for organizing and sharing information between objects.
Exactly. And it gets even more interesting when we start talking about constructor functions and the difference between proto and prototype.
Right.
And maybe we should save that for the next part of our deep dive.
Sounds good. All right, so we've established that prototypes are like these JavaScript family recipes, and objects can inherit properties and methods from their ancestors. This prototype chain is starting to make sense, but I have to admit, those terms proto and prototype
Yeah.
still kind of trip me up.
That's completely understandable. They sound very similar, but they represent distinct parts of the system. Think of proto, like an invisible string connecting a child object to its parent prototype. It's like the child's way of saying, hey, I get my features from you.
Gotcha.
Prototype, on the other hand, is the blueprint itself. It's what constructor functions use to define what all objects created from them will have.
I think the analogy is helping. So proto is the link, and prototype is the actual blueprint. You mentioned constructor functions. Are those like specialized bakers in this analogy?
That's a great way to put it. Constructor functions are a way to create objects based on a specific prototype. They are like master bakers who follow a particular blueprint to make cakes. Let's look at that code snippet with the animal function again. Function, animal.animal, animal.prototype.speak, console.log makes a noise, const dog, new animal dog, dog.speak.
Yeah, this one always seemed a little more formal than just creating a plain object. What's the key difference here?
The key here is that we're defining a function animal, and then using animal.prototype.speak to add a speak function to its prototype. So any animal created with this animal function will inherit the ability to speak.
So it's like saying every cake made by this baker will automatically have frosting.
Yeah.
And then when we create dog with new animal, dog,
Right.
it inherits that speak function.
Exactly. And when we call dog.speak, it logs dog makes a noise because it inherited that ability from its prototype.
This is really clicking for me now. So constructor functions are all about setting up these blueprints, these prototypes.
Yeah.
And proto is how objects actually access those blueprints. But earlier you mentioned ES6 classes,
Yes.
a more modern approach. Do those fit into this bakery somehow?
They do. ES6 classes are like a newer, more streamlined bakery that still uses the same base recipes.
Okay.
They just provide a cleaner syntax, a more elegant way to write the same logic.
Okay, so it's like having a fancy stand mixer instead of doing everything by hand, but the underlying baking principles are the same.
Right.
Let's see this new bakery in action. What's that code example with the vehicle class?
Right here it is class, vehicle sim. Start, console.log, starting a start, console.log, starting make, console.log, starting this.model make, console.log, honk, console.log, starting model, console.log, mycar.log, mycar.soncle, honk.log, mycar.honk, mycar.honk.
This looks much cleaner than the constructor function example. What's the secret ingredient here?
The magic word is extends. It's telling JavaScript that our car class is inheriting from the vehicle class.
Gotcha.
It's like creating a deluxe cake based on our base recipe, but with extra toppings. And notice the supermake call in the car constructor. That's calling the vehicle constructor to make sure the mental property is set properly, inheritance at its finest.
So my car can both start because it's a vehicle and honk because it's a car, all thanks to inheritance. And that behind-the-scenes prototype magic, this is so cool. But with great power comes great responsibility, right?
Yeah.
What are some best practices to keep in mind when working with prototypes and inheritance so we don't end up with a kitchen nightmare?
That's a very important question. You don't want your cake to fall flat, so to speak.
Right.
One crucial tip is to focus on adding methods to prototypes, not data properties.
Wait, why is that? Shouldn't everything go on the prototype?
Not necessarily. When you add a method, like our speak function for animals, it's shared by all instances. It's like everyone using the same recipe instruction booklet, but if you add a data property directly to the prototype, like age for person, each instance gets its own copy. It's like everyone needing their own separate measuring cup.
Ah, so it's about efficiency. If every cake needs its own unique amount of flour, you don't want to specify that in the shared recipe. Okay, what other potential kitchen disasters should we watch out for?
Another big one is directly modifying the proto property.
Okay.
While you can technically do it, it's like messing with the plumbing of your bakery. It can lead to all sorts of unexpected consequences and is generally considered bad practice.
Yeah.
Stick to using object.create or ES6 classes. They're much safer and more predictable.
So don't mess with the secret behind-the-scenes connections. What about inheritance chains? Any tips there?
Yes, keep those chains short and sweet. Think of it like a game of telephone. The more people involved, the more likely the message is to get distorted in JavaScript. When the prototype chain gets too long, it can impact performance because JavaScript has to climb through a lot of ancestors to find what it needs.
Makes sense. It's better to have a clear, direct line of inheritance. Speaking of things going wrong, debugging prototype issues can be a real headache. What are some common mistakes people make, and any tips for when things inevitably go sideways?
One common pitfall is unintentionally overwriting prototypes. It's like accidentally spilling food coloring into the main batter and suddenly all your cakes are pink. For example, if you accidentally assign a new value to array.prototype.sort, you've just changed the sorting behavior for every array in your application, which could lead to some very unexpected results.
Oh, man. I'm suddenly getting flashbacks to those late nights debugging weird sorting issues. It's like playing prototype whack-a-mole. So double check those prototype modifications. What else should we watch out for?
Another common mistake is forgetting to call super in subclass constructors. It's like forgetting to add the baking powder and ending up with a very dense cake.
Right.
Remember, super calls the parent class's constructor to make sure inherited properties are initialized correctly. Always make sure you're calling super appropriately when working with inheritance.
All right, super important. So we've got our baking tips, our safety precautions. But why does all this prototype and inheritance business matter in the real world? Can you give us some examples where these concepts really shine?
Absolutely. Let's think about a real-world scenario, building a social network. Imagine you need to represent users, their profiles, and their posts.
Okay, I can see where this is going. Users have a lot in common, like names, usernames, profile pictures.
Right.
But they also have unique aspects like their list of friends or the content of their posts.
Exactly. This is where prototypes and inheritance come in handy. You could create a base user prototype with the common properties and methods that all users share. Then you could create specialized prototypes for different types of users, maybe admin user or guest user that inherit from the base user prototype and add their unique functionalities.
That's super efficient. And you could apply the same logic to posts, right?
Yeah.
A base post prototype and then specialized prototypes for different post formats like text posts, image posts, or video posts.
You got it. Prototypes and inheritance allow you to create these relationships between objects, promoting code reuse and a clean structure. It's about making your JavaScript projects more organized and manageable.
It's like having a well-organized bakery where every recipe has its place and you can easily adapt and extend recipes to create new and exciting variations.
That's a fantastic analogy, and just like a good bakery runs smoothly and efficiently, understanding prototypes helps you write JavaScript code that's not only powerful, but also easy to understand and maintain.
So we've covered a lot of ground from family recipes to fancy bakeries and social networks. But I think it's all starting to click for me now. Prototypes are like the secret ingredient to writing well-structured, object-oriented JavaScript.
It's amazing how seemingly complex concepts can become so clear with the right analogies. We've gone from family trees to bakeries and now social networks. I think I'm finally ready to tackle prototypes in my own code.
All right.
But before we wrap up, I'm
Okay.
curious, are there any other real-world examples where prototypes really shine?
Oh, absolutely. One area where prototypes are incredibly useful is in building reusable UI components. Imagine you're creating a web application with lots of buttons, drop-downs, modals, all that good stuff. Yeah, I can see how that could get repetitive quickly if you had to write the code for each button from scratch.
Exactly. But with prototypes, you can create a base component, like a button prototype,
Okay.
with all the shared functionality, event handling, styling, maybe even some animations.
So it's like having a template for a button, and then you can just tweak it to create all these different variations. That's incredibly efficient.
It is, and it keeps your code DRY, don't repeat yourself.
Right.
Plus, if you need to change something about all your buttons, you
Yeah.
only have to change it in one place. The base button prototype and all the other buttons inherit that change.
That makes maintenance a whole lot easier.
Yeah.
Any other examples come to mind?
Think about data processing. Say you're working with different types of data objects, customer, order, product. They might have some shared properties like an ID or a timestamp, and they might all need to be validated or formatted in a certain way.
So you could have a base data object prototype with those shared properties and methods, and then each specific data type would inherit from that and add its unique data points.
Exactly. Prototypes and inheritance help you create a hierarchy of objects that mirrors the relationships in your data. It's all about creating structure and avoiding redundancy in your code.
So to recap, prototypes are like these blueprints for creating objects, and they allow objects to inherit properties and methods from their ancestors,
Right.
forming this prototype chain.
Right.
We learned about constructor functions, the traditional way to set up prototypes in ES6 classes, the more modern approach. And we even talked about best practices like adding methods to prototypes instead of data, avoiding direct modification of proto, and keeping inheritance chains short and sweet.
Absolutely.
And we explored how these concepts apply in the real world, from creating social networks and UI components to processing and managing data.
It's been a fascinating discussion.
It has been a fascinating deep dive.
Yeah.
I think I'm finally starting to see prototypes not as this mysterious, intimidating concept, but as a powerful tool for writing better, more organized, and more efficient JavaScript code.
And that's the key takeaway. Prototypes are a fundamental part of JavaScript. Once you understand how they work, you'll be able to write more robust, maintainable, and truly object-oriented code.
Well, folks, that wraps up our deep dive into JavaScript prototypes and inheritance. We hope you've gained a clearer understanding of these essential concepts and are excited to start applying them in your own projects.
And remember, if you're ever feeling lost in the world of prototypes, just think back to those helpful analogies. Family trees, bakeries, and social networks, they'll guide you on your way to mastering this powerful feature of JavaScript.
Next time on the deep dive, we'll be tackling another exciting aspect of JavaScript asynchronous programming. Get ready to unravel the mysteries of promises, async await, and callbacks. Until then, happy coding.